So recently we've been working with right-angled triangles. Today's topic is sine law for non-right triangles. So our goal is to learn the formula for the sine law and how to use it in non-right triangles. So unfortunately not all triangles are right triangles. The primary trig ratios, so our SOHCAHTOA, can only be used for right-angled triangles. But we can use the sine law to help in some of these situations where we don't have right triangles. So the sine law involves ratios. So it's the work that we're going to do is going to seem like a lot of the work we've done with similar triangles in our ratios. I won't talk too much about the actual formula at this point. We'll look at some examples and you'll see how it works. This note is important though. To use the sine law, you must know the values of partners. So I'm going to be asking you to look for partners in questions. And all that means is that if you know one side length in the triangle and its opposite angle, I refer to those as partners. So if you know partners, then you can use the sine law when you're dealing with non-right angle triangles. So example 1 here, we're just trying to find the length of side x using the sine law. So one thing we're going to do here, I'm going to actually put letters in for the angle so that we can identify the different sides and angles there. And when we're labeling a triangle, we use capital letters for the angles, and we use small letters for the sides. So I've got the capital letters for the angles. So side A is opposite angle A, so this would be side A. Side C is opposite angle C, so this would be side C. And side B is opposite angle B, so that would be side B there. So what you notice in this situation is that we have partners right there. The angle B and side B we know, so here we've got partners. The other information we've got is angle A. So because I've got these two guys that I'm working with, because I'm trying to find the x there, so I'm going to work with the A angle and the B angle. So what that means is that, and this is similar to our similar triangles work, we don't need to use all three of these ratios. In this case, we're going to use A and B because we know nothing about angle C or side C in this case. So I'm going to write down sine A over A and sine B over B. And then I'm going to substitute in what I know. So I know angle A. So angle A is 128 degrees. Side A is where the x is, so I'll put an x there. Angle B is 23 degrees. So I'll put that there. And side B is 22.2. Okay, and then if we cross multiply, so I'm going to have sine 23 times x. Excuse me 1 second, I have a phone call. All right, I'm back. So we're cross multiplying here, sine 23 times x. And on the other side, we're going to have 22.2 times sine 128. And so if we want to get x by itself, we're going to move that sine 23 to the other side of the equation. So what we're going to end up doing is 22.2 times sine 128, and then we're going to divide that by sine 23. So I'll show you on my calculator what that's going to look like. Just move it over here. All right. So, again, making sure that your calculator is in degrees. So I'm going to do 22.2 times sine 120, whoops, back up there, 128, and then divided by sine 23. Make sure that looks okay. I'll hit enter on that. So I get 44.7. I want to round it to one decimal place here. So in this case, x is going to equal 44.8 meters. So with our experience in dealing with ratios and solving equations that involve proportions like this, you should be able to handle these. The only new thing is that we're dealing with sine as part of these ratios. But you should be able to handle that okay. All right, so that was finding a side. Now we're going to take a look at finding an angle. So in this case, if I'm looking at this question, and remembering that I want to use sine law if I have partners. In this case, my partners are with side B and angle B. So here's my side B, and there's my angle B. And I'm trying to find angle A, so I'm trying to find that angle. And I know side A. So same as last time, I'm going to use A and B fractions. So sine A over A equals sine B over B. We're going to have sine theta over 5.1. And we're going to have sine 65 over 5.6. So really important that you get everything plugged into the right place, and remember that the angles go with the sine parts. So in this case, if I cross multiply, so I'll multiply here, I've got 5.6 times sine theta equals, and then I cross multiply here, I get 5.1 times sine 65 degrees. And then I want to get sine theta by itself. That's what I'm trying to solve for. So sine theta equals, and when I move the 5.6 to the other side, I will be dividing by that. So on my calculator, if I do that calculation, so I'm going to do 5.1 times sine 65 divided by 5.6, enter. And I'll round that to 4 decimal places. So here I've got sine theta equals 0.8254. But I want to know what theta is equal to. I don't want to know what sine theta is equal to. So when I move the sine over to the other side, remember that it changes to sine inverse. So to find the angle, it's like we're working backwards. So I have to put in sine inverse. So second sine gives me sine inverse. I'm going to put 0.8254. And then I hit enter. And I want to round this to the nearest degree. So that means that theta, or A, is equal to 56 degrees in this question. Okay, let's take a look at the last example here. So in this one, we're given some information. We've got to actually draw the triangle. I've mentioned this before. Don't be concerned too much about when you're drawing these triangles that they are perfectly drawn to scale or anything like that. So in this case, I know that angle X is a 35-degree angle. So I'm going to draw a triangle that has about a 35-degree angle. So that's about a 35-degree angle there. Okay, so that's where I'm going to put X. That's where I'm going to put the 35 degrees. Then I have Y, and I have X, the side length. So when I look at, so this is going to be side X over here. So this is 42 centimeters. And then Y has to be longer than that. So I'm going to pick the longer side and make this Y here. So that's going to be 64 centimeters. That means that that's angle Y, because it's opposite side Y. This is my Y. This is my X. So that means that my other angle there is my Z. And as we've been doing, if we're looking for partners here, those are my partners. So I'm working with the X's and I'm working with the Y's. Okay, now, they're asking me to solve the whole triangle. There's nothing I can easily find right now without using trigonometry. So I'm going to have to use the sine law first to find angle Y, and then things might get easier after that. So I'm working with the Y's and I'm working with the X's. So sine Y over Y and sine X over X. So I don't know angle Y, but I know that side Y is 64. I know angle X is 35, and side X is 42. Now, if you reach a point where you can save yourself a step here, that's fine, because we know that ultimately what's going to happen is I'm going to cross multiply these two, and then I end up dividing by the guy who got left out here. So on the other side here, it will end up looking like 64 times sine 35 divided by 42. So Y is going to equal the sine inverse of 0.8740. And then it keeps on going. When you punch it into the calculator, just to keep it as accurate as possible, I'm going to suggest that you do this. Let me just clear this. So I'm going to do the 64 times sine 35 and then divided by 42. I'm going to leave that decimal in my calculator with all those numbers in the decimal. And then I'm going to do second sine inverse. And I want to take the sine inverse of my last answer. Now on some calculators, when you hit sine inverse, it will take the sine inverse of the number that you have in the calculator right now. Some of you may need to use the answer button on your calculator. So on my calculator, the answer button is just above the minus sign, I believe. Let me try that. So, second. Yeah. Okay, so I'm taking the sine inverse of my last answer, and I get 60.9. So I'm going to round that to the nearest degree. So in most questions, you can see we round the angles to the nearest degree and sides to 1 decimal place. So in this case, angle Y is going to equal 61 degrees. So let me get rid of this guy for a sec. So if we know that angle Y is 61 degrees, to solve the triangle, I still have to find angle Z, and I still have to find side Z. So now that I know two angles, I can find angle Z by doing 180 minus the 35 minus the 61. And when I do that, I come up with angle Z is equal to 84 degrees. So now to find side Z, I can use my partners that are the x's, so I can use these guys with the z's this time to find side Z. So if I write those fractions, I'm going to use the x's with the z's. So an angle x is 35, sine 35, over side x is 42. Angle z I just found was 84, so sine of 84 over, and side z is what I'm trying to find. So if I do my cross multiply and divide, it'll look like this. So I'm cross multiplying these two and then dividing by the other one. So it's going to be 42 times sine 84 divided by sine 35. So if I do that calculation and we round to 1 decimal place, you'll come up with 72.8 centimeters. Okay, and then our triangle is solved because we found everything that we didn't know. One thing we'll just make a note of at the end here. The sine law doesn't work if you're finding obtuse angles. So if you're trying to find the biggest angle in a triangle, and it's greater than 90, you should never use the sine law to find that angle because it won't work. You'll get actually an angle that will say that it's smaller, but it's actually bigger. So you should never use the sine law to find the angle opposite the longest side of the triangle, just in case it's obtuse. So if you have a choice, you want to find one of the smaller sides. Okay, great. We'll see you tomorrow.